Hey, this is Bobby from Copal TV Repair with a video of a Samsung power supply board belonging to Michael Pavillard. No, I'm sorry, Craig Pavillard. See Pavillard, sign here. Probably that. I don't know whether it's signed on the back. I don't see it anywhere, but just in case, so that the customer knows, this is their board. And the reason I'm making this video for them is to show them that we tested and it is working. And they said it doesn't, and I actually believe them, because the first time we tested it, after it came back, it wasn't working either. It wasn't turning on. And this board does have a known issue with the solder, the quality of the solder that is being used, and some solder joints that are more prone to degrading and failing over time. We reflow a lot of them, actually. And I looked at those, and other than one not so clean reflow that was done by whoever did the board here, I couldn't find anything. I did clean it up. It was just excessive amount of solder there, like they would be short. But if there was, it probably wouldn't have passed QC in the first place. Anyhow, I tested it. It didn't show anything. I mean, there was no power. It just says the customer reported. So I can confirm there was a problem. And then I looked very carefully, found nothing wrong other than something that I don't think that was the problem. Because if it was shorted, it would have been a louder bang, and it would not have passed our QC in the first place. Unless it was microns and something there, but that's hardly ever happens. I mean, it's just theoretical explanation. Anyhow, I cleaned that solder joint on a standby power driver, this guy on the back. And I turned it on, and ever since, every time I test it, it is just powering on fine, and that's what I'm about to show. I've shown how to test this board, and we have other videos, I believe, on it, so this time I'm not going to be explaining in great details what goes where. What I'm going to do is I'm going to stick one probe here, and the ground is going to be the negative probe, the positive probe, so I'm going to be getting negative results here, but that is because one of my probes is very thin and easier for testing, negative one, and this one is thicker, and it's more convenient to do it this way. So when I do this, I should be having standby in one of those. Let me see. Okay, that's second pin is PSO, so this pin has to be grounded in order to turn the power supply on, and I have this little jig that we have for the purpose, which makes the power board. I hope you will be able to hear the click. I'll get this closer to the relay here. I don't know if you heard it, but it did the click. And once the click is done, let me see if I should be having the VA. No, the VA is still not up. It will come with the VS, but some of the other voltages on this connector will be available. Now there is 5 volts here. I'm going down on the pins with the tin probe. Okay, I have 15 volts here. I'm going further down. There won't be many others. 5 volts somewhere. And there you go. And what I have is I have one button here on this jig that allows me to activate the VS. So VS is right up. And when I press that button, that's gonna be a stretch. When I press that button, and this is my hand here, I'm pressing it with my pinky. I have 220 volts, especially if I touch it properly. Come on. All right. I overloaded for a second because I pressed it while it was off. So let's do it again. There you go, 220. If the board is loaded, that's not going to happen. VA should be showing up as well, but it's going to be harder to touch. VA is hidden right here. It will be just a pain in the butt to do without help. But if the board doesn't switch off, the VA does come. You'll just have to trust me that it does. Or I'll have to call somebody to help me with the video. It does. The problem is elsewhere. The problem is that the board is working fine now, and I can't get it to stop working. I mean, this is as much as we can do. I will communicate the rest. I just wanted to show that, you know, the board is working fine in test, and it wasn't starting at all before. It wasn't clicking when signaled here. I don't remember whether there was I don't think there was a standby voltage coming here. And the very few times when I've seen something like that happen, the problem was in the microcontroller here. We had to replace it a few times. It has a built-in firmware, fairly simple, but it is what it is. And I was thinking that it will be the same, but it wasn't. I mean, it didn't change it. It is working fine now. The board was actually working in both cases. It would be producing the standby voltage. It will be going out of the primary transformer for the standby voltage, the small one. But the microcontroller would not be releasing out the PS on voltage here. So whether you signal it or not, it was in 4.3 volts that you can ground and tell the board to power on. On this board, it looked the same. There was output voltage and there was nothing going out here. That's why I thought it was the microcontroller, but it isn't. So this is as much as we can do. Just wanted to show you. Thanks.